Given the information shown below, calculate the speed of the wagon on the far right at the given height. So on the left, it's going 12 meters. It's 12 meters high, and it's traveling at 8 meters per second downwards. And on the right, it's 7 meters high. So what I'm going to do with this is I'm going to make a little change in all this. I'm going to call the 7 meters where the height is equal to 0, and I'm going to make the 12 meters, on the left-hand side, I'm going to make the height 12 minus 7. So in other words, I'm going to make it just 5 meters above. So that's going to be the height on the left. It's going to be 5 meters. So 0 on the lowest height, and then 12 minus 7, that's the difference, and that's going to be on the left height, the starting height in this case. All right, so when I'm taking a look at this problem, I'm going to use energy relationships to solve it, especially out of this unknown curve and everything. And I'm interested in the difference in height. When I'm looking at it, I need two locations to compare. So I need two locations where I know the velocity and the height. So on the left, well, I know the velocity and the height, and on the right, I know the height, and I want to figure out what the velocity is going to be over here on the right. So that's great. That's going to help me out a lot. That's what I want to know. All right, so that's going to give me two locations to compare. So I'll start with conservation of energy. Conservation means equal. So I'm going to sum up the energy, and I'm just going to write a little, let's see, I'll write left over here. And that equals the sum of all the mechanical energies on the right. So on the left, that's going to be kinetic energy on the left plus potential energy on the left equals whatever the kinetic energy is on the right plus potential energy on the right. All right, now I'm going to go through some simple questions to figure out what goes away and what stays. So kinetic energy is about motion, and potential energy is about higher than the other location I'm comparing. So on the left, is it moving? Yes, it's moving at 8 meters per second. So I want to keep that in my equation. So that's going to be down here. That's going to be 1/2 mv squared for the left. Next question is it above the other location's height? And the answer is yes. So I'm going to keep that too. Plus mgh equals. On the right, is it moving? I think so, because that's what I'm actually kind of solving for here. So 1/2 mv squared. On the right, is it above the other location's height? Well, no, it's lower. In fact, I'm making it h equal to 0. Since h is going to be equal to 0 there, that's going to go away. Now, just as an aside, you could say that the height on the right is 7 and use mgh with an h of 7, and on the left, use mgh with an h of 12. It'll still work out. The math will still work out and give you the same thing at some point. So that's really doesn't matter so much. All right. You just got to be consistent. So I look at this and I can see the masses are going to go away. Mass, mass, mass. So that leaves 1/2 v squared on the left plus gh on the left equals 1/2 v squared on the right. To isolate my v on the right, I'm going to multiply both sides by 2. So 2 times 1/2 is just 1. That leaves me with v squared plus 2gh equals, well, 2 times 1/2 is 1, so that's going to leave me with v squared right there. And then to get this, what I'll have to do is I'll have to continue this up here. And the velocity on the right, so I'm just going to kind of start putting a little bit of notation here. That's going to equal the square root of v squared on the left plus 2gh. I'll put in my numbers here. V on the right, I'll call it RT now, is equal to the velocity on the left. So that's 8 meters per second squared plus 2 times 9.8 meters per second squared times my height difference, which is 5 meters. Of course, all that is under the square root. When I find that, the velocity on the right comes out to be 13 meters per second. It says velocity, but remember, we're talking about energy, so actually it's the speed because it doesn't have direction.